Well, this is an unusual way to start a video. What you see here in front of the camera are 3 discharge tubes. Each tube has some kind of gas in it, and they're hooked up to a device where when you turn it on, the gas is made to glow. So what I'm illustrating here is some of Kirchhoff's laws, and in particular the connection between Kirchhoff's laws and atomic structure. So when you turn these on, it turns out that the gas is something called excited. Electrons go into an upper level and then they fall back down. But each tube has a different gas, and you can see that each tube gives off a slightly different color in the camera. And what I also have is something called a little grating. It's called diffraction grating. What it's going to do is it's going to split up the light into a spectrum. Okay? So I'm going to hold up the grating in front of the camera as we turn on each of these, and we're going to examine the spectrum. Now, I'm going to start with the one on the left. The one on the left is actually hydrogen gas that's in this tube, and when I turn on, it takes on a kind of reddish purple kind of color. Now, it turns out I was practicing, so it's just a little bit faint. When I put that grating in front, you see a red line. A red line pops up a little to the right and to the left as well. I don't know that you can see the blue line. There should actually be 2 blue lines in there too. One that's a little turquoise and one that's a little more blue-violet. Okay, take it away, put it back. There's a red line there. Those are the Balmer lines, the first 3 Balmer lines of electrons going from 3 to 2 for the red one, 4 to 2, and then 5 to 2, and then they start getting really faint. Okay. Let's look at the middle one. Different gas. This happens to be neon. To me, it looks a little bit red-orange. In the camera, there's a strong red glow to the right and the left is reflected off here. Now, when I put the grating in front, you can see that there's a mishmash of red and orange lines to the left and right. See, they come out. It's just a mishmash. You don't see really too many distinct features. You might see a little bit of yellow over there on the sort of inside of the red glob, if you will. It's a very complicated spectrum. There's just a whole mishmash of red, orange, and yellow, and then there's some green off to the side, which I don't think shows up in the camera. Turn that off. The last one is actually helium gas. Okay? So whereas hydrogen has a proton and an electron, helium has 2 protons, 2 neutrons, and 2 electrons. More of a sort of white color to it. Get a little bit of red reflection off the inside of the casing here. It's basically white on the tube. And when I put the diffraction grating, there's a whole bunch of really strong lines that pop out. They're brighter than the hydrogen ones, as it turns out, for this, and they're less complicated than the neon gas. There's clearly, you can see the sort of blue purples, a green, a yellow, and the red. Okay, so each gas has its own distinctive pattern of spectral lines, and that pattern of spectral lines relates to the atomic structure of the gas, number of protons and electrons, and where they happen to be. These are examples of emission line or so-called bright line spectra associated with Kirchhoff's laws, and they represent the fingerprint, the way by which astronomers can identify different kinds of gases in distant objects like stars without actually being able to go get a sample and bring it back to the laboratory.